Hi there, and welcome to this tutorial series on texture artistry with Substance Painter. In this video, I'm going to be talking a little bit about the theory of PBR, which is the rendering system that Substance Painter is using. If you're familiar with PBR and how it works, then skip to the next video, you're good. But if you're really fresh to 3D and Substance Painter, this is your first year of study, then maybe just hang back and you may learn something from this video. So Substance Painter is based on a rendering system called PBR. PBR stands for physics-based rendering. What this means is that the light we're simulating as we're rendering and the materials that we're simulating with our shaders are all based on real-world physics and maths. So they follow the rules of the real world. The benefit of this is that it does realism really well. That's for a start. Now you don't have to use it to create realistic things, and you don't have to go for realistic art if you want to use PBR. However, it is very, very good at achieving realism. The other benefit to it is that because the underlying maths, the underlying science behind your light and your materials is constant, it's the same, then you can swap out your settings very easily. You can swap out materials very easily. You can change up your lighting settings very easily. You can change up between night and day, summer or autumn settings just really, really easily, and it'll all look convincing and realistic. Once you've decided something is a metal, then it'll behave in a metal regardless of the kind of lighting that you are using, which is great. Really, really, really cool. Really good. So it takes some of the hassle out of it all. If you want to know more about PBR, so the theory behind it all, then there is the PBR guide written by Logarithmic, who are the developers of Substance Painter. It comes in two parts. One is all of the science stuff, all of the big maths words or the big science words. I still recommend reading this through even if you don't entirely understand everything that's going on. But you will glean something from it. The second part is what does this mean for us as artists? And I mean, this is the good stuff. This is what it means. This is the helpful stuff. But because it's based on the theory, you do want to at least glean through this first part. So go check that out if you're interested in this, or if you want to just know more. So general ideas behind PBR. So I'm just going to go through sort of points to keep in mind whilst you are painting for PBR. First one is that light, it travels. It is a light, so it is a wave. It is a wiggly line. So I just want to go and paint a little bit. It is a wiggly line, somewhat like this, or somewhat like that, depending, on the color of it. It travels from a source and it loses energy the further away it moves from that source. So that's idea number one, is that light will lose energy as it moves, as it travels. When light hits an object, there's 3 ways it can really interact with an object. It can bounce off the surface, and this is what we call reflection. If you've done some high school science, you will probably remember that the color of an object that we see is the color of light that is actually bouncing off the surface of that object. So if something's red, all the other colors of light are being absorbed by the material, but the red is bouncing off and being detected by our eyes. You'll also see some color bleed in the real world. So if a red object is sitting next to a white wall, then some of that red light will actually bounce off and kind of tint that white wall a little bit if it's really close to it. Something to keep an eye out for. Sort of helps with achieving that realism or believability. So light can reflect off a surface if it hits it. Second kind of interaction is what we call transmission, and this is what happens when light passes through glass or water or a similar sort of clear material. So what's happening here is light is just passing right through. In Arnold, this is referred to, so the Arnold renderer, it is referred to transmission. In other renderers, you may see this referred to as refraction, whether it is a refractive material. Refraction is what's happening when the light is sort of bent. You can see this pencil just at the top here is being bent in that reflection there. That's refraction, whereas like the actual passing through is what we call transmission. So, that's why you may see a different word, is that refraction is the word we're more familiar with, but, there's a more accurate one that we can use. So yeah, light can either be reflected or it can bounce off. It can be reflected or it can pass through a material, but it can also get trapped. So some light in some materials sort of like starts to enter a material, but again, that gets stuck in the volume. And this is what we call scattering. So I'll just go and show my example of that. So you've seen it probably quite a lot. So if you ever held your hand or up to a torch, or put a torch up to your mouth if you were a kid, and then turned the torch on, then you would have seen your hands or face glow red. And what's happening there is that the red light is entering your skin, it is passing through it, but then it gets stuck in the volume of your hand or of your face, and is making the interior of you glow. And it's not just skin and flesh that has this property. So things like marble, clay, wax, shell, a lot of food will have this, like milk and juices, and gelatins, chocolate has subsurface properties, and even some plastics. And shell also has a subsurface property. You may hear this property be called translucency as well. So sort of keep an eye out for that one. Subsurface scattering and translucency are pretty similar ideas. Alright, so you've got those three main interactions of light. It can be reflected, it can transmit through a material, and it can be scattered if it tries to enter a material. So two other ideas to think about whilst you are texturing with PBR is that materials on surfaces and materials on a sort of a molecular microscopic level can be very smooth or very bumpy. And we'll take a look at a diagram just here to make it a bit clearer. So here, imagine this is, we're very, very close up to a surface, maybe something metallic, and light will hit that metallic surface and it will bounce off pretty uniformly because a metal is generally very smooth at a microscopic level. But for other materials, say, rock, wood, some plastics, if it's been damaged, will hit a material, the surface of a material, and they'll still reflect off, but not uniformly, sort of at scattered angles. And this is what we are mapping when we are mapping with a roughness map. The tiny little bumps that we see here are called microfacets. So if you see that word, that's what it's referring to. These are just tiny, tiny details in the surface of your model that you wouldn't even texture with a bump map or a normal map. They're just so small that they're on a microscopic level, but they still impact how light plays on the surface. So it's still worth texturing on. It can make a really big difference. So I'm going to turn on this plastic over here. At the moment, it is quite rough. It's got a high roughness value. We can see that the light sort of looks, it's still reflecting a bit off that surface. I still have that gleam just there, but it is a very blurred reflection. Oh, well, I can say the roughness, oh wait, there we go. But if I decrease that roughness, then that reflection is getting tighter and tighter and tighter. And you can almost see the environment. You can see the sky of that environment in the reflection. So very low roughness materials means it is very smooth. You do not have exaggerated microfacets, but if you increase your roughness value, then you can get a very sort of matte sort of look. It is still reflecting, but it is very sort of scattered and dispersed. So you do not see a clear reflection. The last thing to think about when you are texturing with PBR is that materials are split into metals and non-metals. Metals used to be pretty hard to do convincingly, and metals actually behave really similarly. So, gold and silver and bronze and chrome are all really similar to each other in terms of how light interacts with them. So it is actually worth our time to saying, look, all of these numbers we'd normally plot in for a metal, let's just bake it into a map, whether we need to do it or not. And that's what a metalness map is essentially doing. White on a metalness map means something is metallic. So you'll see it on these edges that have where the paint has rubbed off on this gun. You can see that it's all white there. And non-metal, so plastic, anything that's sort of an insulator, including the paint that's on top of a metal, if the metal itself has been painted, that is represented with black. It is not interacting with the light in the way that metal does. If metal has corroded or oxidized or rusted, the rust itself or the patina you're seeing doesn't behave like metal in regards to like how it interacts with light, so it is represented with black. So you do not paint metalness where something is rusty. Only when you can see the sort of gleaming metal is where you would paint metalness. There are some materials that have the same kind of luster as a metal, like pearl or a fish scale or an insect shell, and you can use metalness to represent that as well. If it has that metallic gleam to it, then feel free to use a metalness property for it, or metalness value for it. So here's my metalness. It is very rough, so we don't see that. But there we go. You can see that can make something look shiny but not metallic, or shiny and metallic. Their sort of shininess and metalness are separate from each other in PBR. Alright, so that's all. So just to round up the ideas that we had today in this video. 1, light travels, loses energy as it travels. 2, light can reflect off a surface. 3, light can pass through a surface, and we call that transmission. 4, light can enter a material and be scattered by it, so trapped in its volume, trapped in the volume of that material. 5, a microfacet is a small bump on like a microscopic scale that still impacts how light is interacting with that surface and is represented by roughness. And then 6, materials are split up into whether they are metallic or not for easiness' sake. Some materials will have a combination of all this stuff going on, so not everything, like you can have something that reflects and transmits and has transmission and translucency or like subsurface scattering all at the same time. Orange juice is an example of that. We're seeing the color and it's a little bit clear, and it also has those like scattering properties. So it's not all or nothing with any of these ideas, but if you've got a handle of all these ideas, then you are more than ready to start painting in Substance Painter.